Alright, I'm starting up the stream. I'm going to check audio for a second. Check, check, check. 1, 2, 3. Looks good enough. I got the quality settings. Let's go! Hey there, A Squared. You were early. You were told there would be a stream. There is a stream now, as was foretold. Okay, so not starting on time. Mostly, I can't start on time on Tuesdays, Thursdays, Sundays because I'm playing World of Warcraft raid. You know, priorities. So, before I start day 15, let me just get stuff set up, the administrative stuff. Get that out of the way, I guess. 15.txt. Take day 14, copy to day 15, then I'll do a little short spiel to explain what the heck Advent of Code is for anyone who happens by. And then we'll get into it, solving day 15 today. There is now a stream, yes. You see how that works? You just have to arrive and then like chat and say you were told there would be a stream, and then poof, there is a stream now. It's funny how that works. Okay, nice clean template. I need to, in my lib, do use day 15 and main, make a 15, and while I'm at it, let's go into the benches, benchmarks, add a 15 there as well. Then give me a terminal, go to 2021, cargo, run 15-1. Aha. I forgot something. I forgot the pub mod. Or just mod, I guess, day 15. Try again. Hey there, Endorn. Test 1, 2, 3. Did you arrive right when I was doing test 1, 2, 3? Very good. Good morning, EU. Hey there, Sureshock. Okay, so we're going to start 2021, day 15 of Advent of Code. What is Advent of Code? Advent calendar of programming challenges. You can do it in any language. They unlock at midnight Eastern time, every day from December 1st to 25th. It's been going on for about 6 years. We're on day 15. It unlocked about an hour and a half ago, right? And the next puzzle is going to unlock in 22 hours, 31 minutes. That's why this counter is here. So I'm going to do it in Rust this year, just like last year. Are you publishing a video on YouTube? I publish videos on YouTube now every weekend, once a week. And the VODs for Advent of Code are also going to go up on the YouTube in a separate playlist. Delay to stream a couple of seconds, delay to streamer a minute. Oh, you mean it took me a minute to start it? Yeah, I'm publishing these videos on YouTube, and I'm also doing a separate introduction to Rust series, which is pre-recorded. All right, are we ready to start Advent Code? Here we go. Day 15, Chitin, or is it Chitin? You've almost reached the exit of the cave, but the walls are getting closer together. Hold on. I ate some chips before, and there's like one caught in my throat. Your submarine can barely still fit, though. The main problem is that the walls of the cave are covered in... how do you pronounce that? Chitins? Or chitins? I think it's chitins, right? And it would be best not to bump any of them. Hold on. The cavern is large, but has a very low ceiling, restricting your motion to 2 dimensions. The shape of the cavern resembles a square. A direct scan of chitin density produces a map of risk level throughout the cave, your puzzle input. So this is like for an example, which means I'm going to take it and put it into our unit test. I love it when the input is just a grid, don't you? You start in the top left position, and destination is the bottom right. And you cannot move diagonally. The number at each position is the risk level. To determine the total risk of an entire path, Oh, I've done this many times. This is the A-star algorithm, or Dijkstra's algorithm, right? Out of the risk levels, they just want us to find the riskiest path, right? Yeah, this is easy. I think I can do this pretty easily. 40, right? In fact, I could just look it up if I wanted to cheat. Is it A-star? A-star is just Dijkstra's algorithm with a heuristic to get there faster. But we could do it with just a branching, like a flood fill kind of thing, if we wanted to just take the longest amount of time. Find it really quickly, you can do something like Dijkstra's algorithm. Yeah, A-star would be like the fastest. All right, let's work on getting the input in first. So I guess I'll just do just a straight on two-dimensional array. So let grid equal input dot lines dot map 9 dot trim dot map or chars dot map char to I don't even need to really do parse, so I can just take that char and subtract binary for 0 and then do as U8 or something, right? Or no, as U8, yeah, and then just do that. And then collect that into a vector. And then collect the outer one the same way. Like that. To do. Gotta put a line there. Okay, turn on my inlay hints so I can see that. Vector, vectors of bytes. All right, good enough. So, see if I can remember exactly what Dijkstra's algorithm is. I can't, but I can look it up. I have this on my quick thing. A-star. Here it is. Dijkstra's breadth first, A-star. Right, that's Dijkstra's. So it's the why does it say Dijkstra's is uniform cost? It's not uniform cost. I forget why it says uniform there. Right, so for every neighbor, we compute the cost to get, there's a cost so far for the current square and add the cost to going to the next. And if we haven't computed the costs yet, or it's less to get there through this path, we remember that, right, the previous path, right, came from. Yeah, so I want to have some, I want the grid to actually be that. So this would be like a cell, and then like back would be some option cell, well, coordinates. U size. And cost. If the total costs aren't going to go up that high, right? I keep it as U8 or am I risking it? Let's see what the puzzle input is. Ooh, no. I think we need more than U8. Big grid. 15. All right, so I guess I'll just be upcasting it to U size. So then I don't want to just collect this. I want to put this into a cell. and make this into the cost. Oh, their algorithm, we have to have a cost so far and a graph cost. So I think I'm gonna have both path cost. How about we just call it risk? That's what it is. Risk and cost. The risk can be U8. So that's risk. Cost. Actually, these two we ought to put in another structure. Like what to call it? They call it cost so far and came from, and they have in separate dictionaries, but I like to group them together. You just had an exam on graph stuff, including Dijkstra. I've used Dijkstra's algorithm a couple times already, so I could recognize it. A star is not appropriate. Why not? A star is just Dijkstra's algorithm with a heuristic to pick the most likely path first. It's a really fun visualization we do for Dijkstra's math. Well, that was in this website. See, there's the visualization. So breadth first. It takes you that long to find it. But you end up going through the woods, and Dijkstra takes a little longer, but you find a better path. Here's the heuristic search with greedy best search. So you either branch out or you try to go towards the goal and you find it really fast, right? And here's the A star. Where's the better one? I thought there was a better one. I think that greedy best is just showing the direction to the goal, but you're supposed to just look at the numbers. Greedy best first will go to this wall first, whereas A star and Dijkstra's kind of end up going up towards because of the heuristic. Something like that. I don't want to read the whole thing to remember. Not a visualization like that, it's a visualization in the data structure and how they modify the traverse graph. Oh, okay. I haven't seen something like that. New meaning to add distance plus risk thing. No meaning to add. That's like the costs of the path cost, right? And then you add the risk to every next step. And because you're trying to find the lowest total cost. I just don't know what to call this thing. Like a step? Yeah. If we stepped on a cell? So that's going to grab these so far. Cost so far, I guess. Or risk so far. Total risk. I just call it cost. And remove that. This becomes step, option, step. All right, and then so I can just down here I can say step is none. So we'll make this mutable, and then if I remember right, I don't remember right. So let me just look at it again. Yeah, it's just like a breadth first search, where we start at the start position, and then we have a frontier which we like pick all the neighbors. Yeah, for next in graph neighbors. And they said not diagonals, right? Cannot move diagonally. Okay, so I've done this before. Why type it again when you can just find it? Here we go. Found my neighbors on day 9. Where did I actually... Yeah, so I used this before, right? So I'm going to just copy that, because we're going to have that down here somewhere. I'll copy it and put it in a comment for now. Okay, so... We, I'm tired tonight, so I just kind of want to look at what the algorithm entailed again. Yeah, I guess we just populate, we have to have that frontier set, right? Let mute frontier equal hash map new, hash set new, because I'm going to be just populating that grid. This is just a set of all places that we have yet to visit. And we're just, yeah, that's right. We're populated at first with 0, 0. So frontier insert 0, 0. And then we have to repeat until we find the path to, it's the extremes. So I need to find the extremes first. That was in here somewhere, right, Mac? Yeah, it's this one? Y range and X range, like that. So we're going to go to the max of both. Really just, I don't need the whole range, do I? I just really just need max. Right? And those stay as use sizes. Okay, and then, I guess we're just looping until, just like this had, right? Until we get to the destination. Where is it again? I don't see... Oh, if current is goal break. Right, we go until we find the frontier. We find the goal in the frontier, so... So why... Actually, I wonder why they didn't break down here. Probably because it's just easier to write it. Okay, so loop... for... Actually, that's what I want. I want this code. That's actually the inner loop. The outer loop would be, actually, it's not a loop. It's while let some chords equal frontier, forget how it was in the flood fill stuff, right? It was this code. I don't know why I can't just write that out. And why do I have to keep looking this up? Yeah, it's while not frontier empty is empty. So let the coordinates frontier, just to get an arbitrary thing off the frontier, and then we let x, y equal chords. That's what I did there, right? And then get the neighbor by adding that. Oh, I have to see if it's in range. Yeah, because we don't want to go off the map, so I do want the X and Y range. After all, yeah, I do want that. Because we're going to use that quite a bit. Alright, so put that back. Put grid there. So, but I can pre-calculate the goal. Let goal equal x range dot end. Yeah, it's end, not n minus 1, right? Yeah. And y range dot end. Remove these. Hey there, Indie Monk. How come it says first time chat? You're not the first time here, are you? Hey there, Crumpet. How are you doing? Posted something in Discord, Twitch channel. You might like it. I'll have to check it out after the stream. How's the day going? Pretty good. We're doing nice Dijkstra's algorithm. I'm too tired to like think of what it was from scratch, so I looked it up in my one of my bookmarks. I bookmarked the thing. If you guys want that, actually, it's just this. This is a great bookmark to have for A-star, Dijkstra's algorithm, breadth first search. That way I don't really have to think. I can just look at the essence of the algorithm and then adapt it to what we want here. So for everything there, I'm trying to remember as much as I can from memory. We look up the risk of that next spot, right? And in the puzzle, was the top left always 0, 0? No, there's a 1 there. So it doesn't count. The 0, 0 doesn't count. Don't count the risk level of your starting position unless you enter it. Okay, got it. And there's no reason to go back to our starting position. So really, this 1 doesn't matter ever. So if it's just enter, then we want to just get the risk of this. Right, I need to do that if it's within bounds again. Yes, this part. Why type it when you can just copy paste it, right? Where did the I-32s go? Oh, I should just put it in a turbofish for now. U-size, U-size. Oh, I see where it came from. It came from neighbors, and that's right. That's what I do want them to be I-32s or I-sizes. So where did I have that? Oh, here. As I-size. We'll just make this I-size. Okay. So if it's within the grid, then we have to have a cost from the starting point, right? Yeah, so when I insert there, I also have to go to the grid 0, 0 and change the set the step sum step with no backcourt. I guess we'll just set it to itself. And the cost of 0. Because it's this cost we're going to add, right? So using the frontier coordinates, so I need to get that. Let last step equal borrow the grid at y, x, and then hang on, what? Oh, that became U-size again? Okay, put the turbofish back in there for now. I can't type. There we go. Oh, right, because it can't be indexed. That's why. Can't index by that. So here it's as U-size. The indexer is pretty picky. It wants U-size there all the time. All right, then there's this conditional where we don't visit it if we found a better path to it, right? This one, new cost is less than cost so far at that next position. Yeah, so let new cost equal last step cost risk plus, oh, I need to look it up now, next step. Let's keep the wording consistent. So next step equals grid y2 as U-size, x2 as U-size. Okay, and then plus next step dot risk. And it's not last step dot risk, it's last step dot step dot as ref unwrap dot cost, like the previous cost, right? Do I have, yeah, okay, that's U-size and that is U8, yeah, as U-size. Okay, if matches, I think, none or some cost if... Can I use like if here? I don't actually remember. I'm not going to do it with matches then because I can't remember. You know what, a better way would be, because this option is tripping me up, is to just always have something in there, but initialize it to 0. So let me just collapse this, just to make it easy on myself. It's just that I have to put in a bogus previous coordinate there, but we'll put in like... But then I have to put a sentinel value in here, like with a very large U size. I hate that. We'll eat the cost of doing it that way. Then I don't need a sentinel value, right? So if next step, we shouldn't call this step actually, because I'm gonna get my words confused. This should be called last cell. And this should be called next cell. If next cell step is none, why did it not help me write that? Because it's I have these backwards. That's next cost. That's next cell. Cell risk. Okay, so if we haven't stepped there before, or I want to say, or we stepped there and the cost is less. So actually, it'd be better just to do a match. Match next cell dot step. If it's none or some step, if step is dot cost is less than, or yeah, less than, no, greater than next cost. Then we step there. Otherwise we don't. That. So to step there, it's to set that back equal to our previous position. So that would be XY. And then, I didn't like that. Oh, I can't do that? Shoot. That's a bummer. So, oh, wait, because I'm using the wrong variable here. I don't want step. This should be next step. Next cell. I already am getting my steps and my cells confused. Step dot step equals some step. Back is that, and cost is next cost. Oh yeah, that can be eye size. Trying to keep the types consistent there. Still, it doesn't like the none though. That's a pity. So that means I have to duplicate this, and I hate doing that. I guess we'll make it into a function. A function on the cell itself, right? Yeah, so let's do that. Step. Mute self. Step. Self.step equals some step. So, hold on. That means I'm going to be repeating this. I have to either repeat the whole thing or at least repeat constructing this and that. It's not worth it. It's not worth it. I'm gonna remove that for now. I'll just copy this code. It's too bad I can't do that right now. Basically, I want that. And why didn't it let me do that? Borrow it? Oh, yeah, we can't mute it. Mutate it? Oh. I see what's going on. So really, match is making this difficult. If I just do it this way. Else if next if I guess I can say next cell dot step dot as ref unwrap cost is greater than. Do that, and then I like how it finishes on. It's just an oh, the next cell has to be mutable. Was that the whole thing? Maybe I could have had a match there. I guess I can try putting the match back in there. It's just this again. And a comma. And then some step if step. I do prefer this because I don't need the unwrap then. Blah 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 blah. It wasn't not like about that. Missing match arm. Oh, indeed, I have a missing match arm. Do nothing. Don't step there. Oh, this can just be mutate that step and say step dot back equals that. Step dot cost equals that. I already have a clock. And I need an arrow. Get rid of that. Yeah. Can't move it out. I guess we'll just reference it. Oh. Can I do that? No, it's not going to let me do it with this. Shoot. Back again. Back and forth. Is none. I just have to then put else if I have to do this weird thing where it's if next cell dot step dot as ref unwrap cost is greater than. And I guess, yeah, just repeat this again. There we go. What's wrong with that, though? Where did I immutably borrow it? Oh, up here. Okay, so I can't. That's true, I can't do that. So what do I need out of last cell? Just the step? Just the last cost? So why don't I just grab that out? Last, well, cost so far. There. Cost so far. What was that? I'm going too fast is what I'm doing. Oh yeah, as step as ref unwrap cost. Wait, what? Identical blocks? Oh, right. It's just saying I can combine these two. Which is right. Should have thought of that. There we go. Taking me a while. Hey there, Anakin Luke. Well, a few people in the Rust community Discord got top 100s. Yeah, they're really impressive, I think. Some ref mute step, you think? Yeah, I'll play with this later. Maybe. So I need to then put it into the frontier also. Frontier.insert x2 y2. Because the idea is everywhere you step becomes the frontier. And then you pull off a frontier position, see what you had stored there before, and then look at its neighbors. And again, like, you can visit the same place a second time if you find a better path there. Otherwise, you don't step there again. And then, oh yeah, we have to check to see if when we pull something off the frontier, have we found it, right? So if, that's right here. If, we can do it this way, right? If chords equal the goal, break, and then we can just pull the cost off the goal here. So it's just off the grid. Goal. Actually, no. I need the individual things right here, right?
Get the right side.
Y rain. Just use goal. Dot 1 0 no dot 1 and then goal dot 0. Oh, wait a minute. We have to check here. So I can just unwrap it. What does it not like about the? Oh yeah, right. I need to map these as use size. Step. Here's where we that'll panic there if we actually didn't find the goal, and then it's just cost as string. They wanted the total cost, right? Total risk of the shortest path. To string. Why didn't like this? Cannot move out of cell. Oh right. As ref unwrap. There we go. Let's run it. See if I did Dijkstra's algorithm correctly. I did not. I panicked. I went out of bounds. So my range check didn't work. Oh, this is -1, isn't it? I was off by 1 there. Thank you for that follow. No, I don't want to run it, actually. Not yet. I want my test to pass first. 57? That's not right. It should be 40. Am I supposed to repeat it until I maybe find a shorter path? What did I do wrong here? Oh, we're supposed to sort them. Yeah, the frontier's supposed to be a priority queue. Okay, I can fix that. I can fix that. So frontier can't be a hash set. It's got to be a binary heap. And import that guy. And we can't just put coordinates in there, actually. We need to Might as well put in a step there and define how to sort them by cost. So let's make this step. Let start equal that. Insert start. I guess I'll just make this a copy type. Derive, clone, and copy. But we're gonna have to define like how when this insert, I guess it's push, right? For binary queue, and this is pop. And this would be let chords, well, let step. I guess we called that something else, right? I don't have a name, so it's last step or last cell. Yeah, last cell equal frontier pop. Okay, and we want to unwrap that. Actually, I can combine these two. I can say while let some last cell equal frontier pop. That's better. And then remove that. Remove the chords. So this becomes if last cell dot I can't use this type. Shoot. There's two. The structures are similar.
Let's talk about structures.
Well, no, I can use the same thing. I just don't want to call it back. Let's call it chords. And we'll call this well, step is fine. It's just that the coordinates for a step from a cell will be the previous step. Chords. All right. Yeah, we have to implement ORD on this thing. I'll do that in a minute. Position. Do that. Position. Actually, yes. Chords. And this is a push. And I actually have to have this whole step in there. Let next step equal that. Some next step. I might have this wrong. I'll have to look at this in a second. I'm taking too long to do this problem. Let's settle the ORD problem. So we need to like sort these by cost, and if I remember right, I usually get the 50-50 chance I'll get this backwards. Isn't it that you implement partial ORD and then you can derive ORD? Isn't that how it works? Like you can just do that? No. I forget how this works. Let's look it up. You can derive partial ORD directly. Is it ORD that I would derive then? So I had it backwards. And I would implement ORD instead. No. Oh, I have to implement partial equal. I can do that one. Still doesn't like ORD. Equal. That one I know you just do that, and that it's like basically a claim that you can swap A and B and they're still be equal. So I want to just say that their coordinates are equal, right? No. We're sorting by cost, so it's if their costs are equal. No, actually we don't, right? How is this priority queue gonna work? Let's look up binary heap. I forget, can two things be equal in a binary heap? You push the same number twice? I think you can, right? Okay, here's how it, like the highest comes first, which is not what we want, right? We want the lowest first. So I'll want to invert my compare. I think that's fine, right? And then, yeah, we just disregard the coordinates. So it would be other dot cost dot compare self dot cost borrow. I think that's what I want. Chords. Wait, what did I do wrong? Oh. Wait, what? I don't need to do that? Did I get this backwards? Again. I don't understand what I'm doing. I always get this messed up. I should just read what this is saying. Your driving orbit implement partial orbit explicitly. What's it telling me to do? Just remove it? But I guess I have to implement both of them? Wait, what? Hey there, Togglebit. How are you doing? You can derive... See, that's what I was trying to do. Derive partial or directly. But it says... doesn't like my ORD because I've derived partial ORD. Don't I have to implement both of them? Don't I? Yeah. I think I do, but like what you're saying, it's just a trivial one, right? Yeah, the only option is... Yeah, so it's just some self compare other. Okay. Don't have hash set anymore. So I hope I got it in the correct order. Let's see if I got it. It panicked at unwrap on 103. It never found the goal. How could that be? Probably because I messed this up completely. So push the starting step. This should go here, actually. Because it holds the cost. The previous... Actually, I don't need to do that. Yes, I do need to do that, because it'll visit that spot again if I do that. If we find the goal, we're done. And then we should be able... There should be a step there. Get that last cell's coordinates. Get its cost. So far. Actually, why am I... Why don't I just get the cost from that last cell? I don't understand why am I doing it this way. Yeah, why am I doing that at all? Why don't I just say this? Doesn't that make more sense? I think that makes more sense to me. Hold on, maybe not, because this can overwrite that. Yeah, I don't trust that. Really, this frontier just has a position in it. I really shouldn't even be using step there at all. I should just be using coordinates. Well, no. I feel like I'm really screwing this up. I should study this a little bit more carefully. Cost so far to current position. So get that from the, basically get it from the grid itself. Add the cost to go to the next one. That's easy. If it's a better, if we haven't stepped there, or if it's a better step than before, then step there with the new cost. Take that priority and put it onto the frontier. Priority queue. And okay. Then what did I do wrong? Why does it not work? Work! Program, work! It's getting out of that loop. It's not finding the goal. So I must have screwed it up. Maybe I got it backwards. Probably not. I should just print out what it's doing. What should I print out here? Print F. Print line. Considering last cell. Waiting for A star instead of A squared. Okay. Look at chat for a second. I've been raided by Sumner Evans. Thanks for the raid. Yeah, I'm in focus mode trying to solve this problem, so I didn't look at chat at all. I'm working on part 1. Using Dijkstra's algorithm, but I'm messing it up. I even have the Dijkstra's algorithm here, and I'm just not, I don't know, I'm not into it tonight, I guess. Sorry about missing the raid for about probably a few minutes. I'll get this eventually. I need my step class, I don't know why I clicked there, to implement debug so I can take a look at what's going on. What did I do? Okay, that's completely wrong. I think the coordinates are messed up. It shouldn't have put 0, 0 back in there. So let's see what I put into the frontier. Next step. Okay, that's wrong. That's what it should be. Was that it? Let's see what I get now. I had the previous coordinates, not the next coordinates. That was it. So here's the path that it found, right? Start at 0, 0. 0, 1 costs 1. 1, 0 costs 1. 0, 2 costs 3. 1, 1 costs 4. 1, 2 costs 4. Costs 6. Costs 7. I want to see where it found a better way around something. Can we see that anywhere here? I guess we would see it as the cost going down, right? I don't actually ever see it going down. It just goes up until it finds the goal. Maybe it's just going around obstacles. Yeah, I would have thought that it would have found a clearer way to go around. Anyway, let's try the real one. This will probably print a lot. Okay, see if I got the right answer. You never know. I could be lucky. Submit. We got it. Of course. Yeah, Dijkstra's in your starter code, so you don't have to think about it. Got you use global error. Oh, nice, Sumner Evans. Had a really, because I saw that it was a pathfinding thing right away, and it, like if I had that code just plop it in there and give me the cost for the shortest path, yeah, that would have been really fast. Test path never does anything fun. Yeah, means that you have to ignore the cost of the first square. Yeah. I got that by happy accident, because what was it when I was writing this thing? I had to put a number here for the start cost, and I'm like, should I put the cost of the first square? And then I went back and read the instructions, and it specifically said, don't count the risk level of your starting position. So I'm like, okay, I won't count it. It's going to be 0, right? So started at 0. So happily did not make that mistake. Yeah, I guess my head's not in it tonight. Like, this is the right algorithm. It's maybe not the cleanest it could be. I just messed up on putting X, Y there instead of X2, Y2. The priority queue is correct. I forgot that ORD is just, that partial ORD is sum of compare. Like, I wish that it would just generate that for you if you do derive partial ORD. What screws me up also is that for equal, it's backwards. You implement partial equal, and then equal is automatically derived by declaration. So I always get that messed up. Let's go on to part 2. Now that you know how to find low-risk paths in the cave, you can try to find your way out. The entire cave is actually 5 times larger in both dimensions than you thought. The area you originally scanned is just one tile in a 5x5 tile area that forms a full map. The original map tile repeats to the right and downward. Each time the tile repeats. So we're just going to do modulo, right? All of its risk levels are 1 higher than the tile immediately up or left of it. However, risk levels above 9 wrap back to 1. So if your original map had some position with risk level 8, then at that same position, each of the 25 total tiles would be right. So same tile, but in the next super tile over, it's 9, wraps down around to 1. Okay, I got it. Each single digit above corresponds. So it's like just scrambling the same map 25 times. I got it. Each single digit corresponds to the example position. Right, okay, here's the full one. So they gave us this example to work with, which is nice of them. They didn't have to do that. But I'm not going to use that. I'm just going to keep it as it was before. So it's this. Because our input doesn't change, right? We're supposed to do that super tiling ourselves. And there it shows me the best path is 315. So let's do this. This I should be able to do faster, right? We have a constant. Whoop, wrong one. We have a constant I need to put in here, which is like super size. I don't know what to call it. What's this factor of 5 called? 5 times as large? I don't know. Super dim? Silly names. Delta time was 1:51:23 for you, big rip. Oh, that's okay. I've fallen on my face a few times. I've gotten like more than 2 hours. EQ is a promise, whereas OR is a real function. No super tiles. This is example of path also isn't any fun. No super tiles? I think it's just that we take our range and it's when we test this, right? So in here, so really I just put this in for that. No, that. And this in for that. And these are both multiplied by 5. Super dim, right? So the ranges are 5 times as large. Oh, wait. Shoot. Back up. I didn't want to touch that, actually. Do that again. I worked all day. That's my excuse. My brain is fried. It's hard to have a full-time job and do this. Not as. Dang it. It's hard to have a full-time job and then to do admin code after work. Okay, so 5 times as large. The goal is at the extreme lower right of the super tiles. And I think we're just going to divide by and mod by No, I need to get that factor, actually. So compute that first, I guess. Let y... what's the right term for this? What's the right term for this? Like y wrap? X wrap? I'm bad with names. I'm really bad with names. So put that there and this there. Because we're going to divide and modulo every time we do this, right? To get the real cost, to get the real risk. Where's the risk? Right there. When we get this risk, we need to add the sum of the xy divided by this the wrap. So let's do that. So I guess we can wait until we get into here. Let me say let x risk x extra risk equal x2 divided by x range. These need to be the same type. Oh, not range. Wrap. Not warp. Wrap. Spell it right, and I gotta get the type right. So hold on. Why don't I just make these as I size, and then I don't actually need to do that. I do because of the multiplication, because those types aren't right. Let's fix that type. Where am I? I'm down here. I don't need that anymore, right? Okay, we're cool. We're cool. So then there's also an a y extra risk, which is y2 divided by y wrap. And also when we look it up in the grid, I need to do the modulo. So I'm kind of thinking I should do that in a function. Nah, it's okay. I can just say let x wrapped equal x mod x wrap. Let y wrapped equal y mod y wrap. And then I need to use these whenever I reference the grid. Okay. And then I need to also do that for x2, y2. Inside here, yes. This is where we use it for the first time. Okay. And then, yeah, again, I need to use the wrapped coordinates whenever I touch the grid. Then I need to add these extra risks. Actually, I could just add them. So I can just say extra risk equals that plus that. It's the Manhattan distance like they told us, right? Oh, and then I have to modulo 10 plus 1. That's going to be a little tricky, right? I think what I want to do is subtract 1, modulo 9, and then add 1, right? So it's going to be risk. You can't see, well, no, you can't see. It's just at the extreme right. Minus 1 plus extra risk modulo 9 plus 1. There we go. It's not going to like all my types here. So risk is this should just be all of that as a U8 to put them into the same type, right? My type's not all right. That's a U8 minus 1 plus extra risk modulo 9 plus 1. The whole thing as U size. This. Did I get that right? So if it's like a 9 and then subtract 1, we get 8. right?
What's all this water?
And then well, let's say it's at 8, right? -1 plus 0 is -1 is 7, plus 0 is 7, mod 9 is 7, plus 1 is 8, right? Now what if its asterisk is 1? So that's 7 plus 1 is 8, still 8, plus 1 is 9. If it's 2, it's 7 plus 2 is 9. Mod 9 would be 0, plus 1 is 1. I think I got that math correct. Then I think that the rest is correct, right? Here, though, I have to... Oh, wait, hold on. I'm putting stuff back into that grid cell, right? So I shouldn't wrap it. I should not wrap for the next cell. I should, yeah, I gotta be careful. I need to store there's stuff I'm storing into the grid. Actually, then why don't I just make this easier on myself and replicate it 25 times, even though it's slower? I hate doing that, though. But I do need this memory. Where's my memory? This option step, right? These risks, we only have like 1/25 of the space filled. These, though, I need to keep all of them. So really, I only need to wrap it when I look up risk. Otherwise, I'm not unwrapping it. I'm not wrapping it. And I do need to expand these. So why don't I do that at this time here? So yeah, let's just do that. Let row row equal that, and row dot expand or resize row dot length times super dim, and the value will be cell default. Row. The problem with that is that this needs to be as usize, and I don't have a default implementation for cell, but we can add that. Implement. Actually, the default should be implementable from that, right? Derive default. Okay, and I need to make it mutable before I can do that. All right, and then after I collect, I need to do the same thing for, I need to replicate. I just need to extend it. So grid dot resize. Yeah, resize. The new length is, I guess we would do with a function, though, right? Resize width. Grid dot length times super dim as usize. The reason I would have a function here is so I can generate a vec of size. I need to know what the size is. So let me just grab that first. I actually have that there. It's y range end. No, it's x range end.
I'm not trying, I just have to be on the edge.
X range dot end times super dim. No, it's already calculated in there. So just that. And that needs to be as usize, because I'm flip-flopping between my types. It didn't like that y.
I just don't
Expected a cell. Shoot.
realize.
How do we make a cell? I guess we just do it this way. Vec. Let row equal vec new. Just do the same thing here. I don't want row length though. I want x range end. It doesn't like me doing that. Probably because this whole thing needs to be as usize. And it doesn't like that. Because you can't clone a cell? What? Oh. Sure, clone it.
I'm close enough to get the boss music.
And there's probably a much easier way to do it. And I'm totally doing this wrong, but that's okay. So that's just extending the memory so that I have enough space to store the path through it. But I'm not bothering to copy the... Actually, if I'm using the memory anyway, why don't I just copy it? And then I don't need to do that wrap stuff on it. Okay, really? I should have split it into two at this point. I should have one set of memory for the risks and another set of memory for the steps. That's okay. Maybe if I split part 1 and part 2 separate. Part 1, it was convenient because we had as many risks as we had potential steps. Here we have 25 times as many steps as we have risks, because the risks are all calculated for the other 24 positions. I'm just gonna, we'll expand the memory, but not worry about the risks. The risks stay the default. Risks stay as default. We're not going to look them up anyway. I just need to be careful what uses the wrapped coordinates. And I just realized I modified part 1. That's okay. We can fix that. Cut. Paste. Cut that out and move it to the part 1. Sorry, part 1. I kind of messed you up. Oh, yeah, these got swapped. Shoot, I messed that up completely, didn't I? Sorry, X and Y range. I'll fix this. We needed X range there. Oh wait, no, it's the same on both, right? Yeah. Like there, right? Okay, let me first make sure I didn't completely damage part 1. No, part 1's still good, right? I still get the same answer, 553. I guess I can remove those prints. Yeah, okay, they didn't damage part 1 too badly. Probably people in chat are like, you're changing part 1. What's my full-time job? I can't talk about it. That's one of the conditions of me being able to stream. Listening to the stream, but now from work. Hope you're having a good day at work, Andorn. Hey there, Cat Peasant. Yeah, I'm not allowed to talk about work. Let's see. Part 2. So here we resized it 5 times as wide, and then I'm getting the width, the complete width, and then we're resizing it vertically 5 times as many. Just making space for it with default cells, right? And then we're calculating, okay, this is wrong. So actually, what I'll do is I'll just say it's y range dot end divide by superdim. Right? It's another way of doing it. Whoops, I did an undo. Oh, and I cut it. I'm just messing up all over the place. Yeah, but that's me. Weird way to, we multiplied and then divide, but that's okay. Where do we use this Y range? I need to make sure I don't... I only should use the wrapped for the risk. So here I wanted to use Y and X and not the wrapped one. So I actually don't want that at all. I don't want to do this either. Where do I get the risk? Right there. Is that the only thing I use next cell for? No. So let's just pull out the risk. Let next cell risk equal almost what I did here, but then dot risk. And that's the only thing I'm going to use the wrapped for. So these should just be y2, x2. And its next cell risk goes there. Right? I think that's right. Is the goal correct? What's the goal again? The range, which is extended. Correct. Okay, and then get our cost. We're in the range, the extended range. We wrap it to get the risk of the next position. Oh, here's where I can add the extra risk directly to that. I can do that. Hold on. Yeah, I should just bake that into that X. So calculate that first. Then take this. Actually, it's that right there, right? So let me just take this whole equation here. No, I don't want to do that. I want to be very careful what I'm doing here. 3 open parentheses, then the rest of this goes there. Then remove the next cost. No, the next cost is that. Costs, yeah, like that. All right. So we wrap the coordinates, we add some extra risk, and we have to wrap it around because it needs to stay as a number from 1 to 9. I don't need to do this as use size because, oh, what's it going to tell me now? Extra parentheses, indeed. So this is a U8. Then we promote it to U size to add it to the cost so far to get the next cost. And if it's better, we step there. Okay, I think this is right. Let's see what I need to remove the print though. Because it's going to print too much. Let's just run it. Should get 315. Yes. All right, cool. So let's just run. What happened to my console? Here it is. Run part 2. 2,858. Yeah, we did it. I don't like how I had to kind of hack the memory that I made though, because I made this decision kind of midway through part 1 that I would combine the where is it, for the grid cells, the risk, and then the memory of the paths through it. And part 2, really, they should be separate. So maybe I should go back and clean this up. So there's the risk, there's the original risk grid, and then 25 times larger path grid. Or another way to do it is while I'm expanding it, I can do this math down here on it. This part. I can do this part while I'm expanding. I'd rather keep it separate and keep this logic the way it is, but instead of you going to this grid for both, this would go to like the risk grid and this would go to the path grid or something like that. That's what I'd rather do. No idea what I did, which is good. You're not influenced by my answer. That my goal has been met. I have not spoiled it for Endoran. But on the flip side, that means that made duck typing, so to speak. No, not duck typing. What is it called? Where you're explaining what you're doing while you're going, like talking to a rubber ducking. My rubber ducking, or talking about what I'm doing as if I was speaking to a rubber duck, is not very good because I didn't explain it in a way that you can understand. That's probably because I got too focused and I was only speaking part of what my brain was thinking. Well, how did I do? I need a little bit of a boost. I wanted to tell me that I did a good job. What did I get? I started late, so it's probably not going to be that good. It's actually not that bad. So if I start on time, I part 1 and 2, I was getting between 2 and 3K, and I thought I was doing poorly there, but like here I started way late and I still didn't get that bad. So that means probably tells me that either it was hard for a lot of people or a lot of people just aren't doing it. It'd be kind of nice to know how many people are trying to do part 1. You know, I have to wait until later to see how many people actually finished part 1, like a day or a week later, to see how many people actually attempted it. Yeah, that's the stats link. This one. But it doesn't tell me how many people have attempted it yet. This, if I just refresh, it'll show like as people are completing. Like 2 more people just passed part 1. 2 more people just passed part 1 and 1 person did part 2. And there's that roll. We were expecting a roll off around here, and it didn't really happen, I guess. Huh. Can solve part 2 without any optimizations? Well, but I had to do the expansion of the grid for the risks, right? I had to at least do that. The math here this has to be done somewhere, right? This is one of the rules of part 2. Thank you for the follow. So I don't know if I wrote this well enough. This is encapsulating the logic of, let's go back to it, where they said in a lot of different words here that the risk is 1 higher than the tile immediately. When they say tile, they mean a copy of the grid, 1 up or left of it, right? So I did both. That's this extra risk, right? And then the fact that it wraps around from 9 to 1, that's this, where you have to subtract 1 and then add the add what you're going to add, then modulo 9, and then add 1 back in. The subtract 1, add 1 is because it's 1 base, not 0 base. It doesn't wrap to 0, it wraps to 1. So the rule about that is if you're going to modulo and you want to start back at 1, you have to subtract 1 first, then modulo, then add 1 back. Right? And it's a mod. It's mod of not 10 but 9 because of the subtraction of 1. Because 0 isn't there, right? There really only are 9 numbers, not 10. It's not 0 through 9, it's 1 through 9. So that's a little tricky. And so we need to have that. The rest of the stuff I did was mostly the same, except what? Except for I did a clumsy way of expanding the memory. I guess I really didn't need to do it that way. Actually, if I separate them, I wouldn't even really need to put it into a vector per se. I could put it all in a 1-dimensional vector to make it even easier on myself. Because once I know the range, then I can just make a single bunch of memory locations for all the potential places on the path that we hit. Or I can just keep it as a map. Guessing A star, what algorithm do I use to calculate the path? Let's use Dijkstra's algorithm. A star is Dijkstra is modified to use heuristic to get to pick the most likely neighbor first. So like in ours, we just picked an arbitrary neighbor. I think that's left, right, up and down, right? So A star would be you consider which of the neighbors is closer to your goal and you try the closer one first. So they had a nice picture of that here. So breadth first, you go out evenly in all directions. Dijkstra's, you go out to the lowest cost ones first with the hope that you'll reach your destination faster, which you usually do. A star, you do like Dijkstra's, only you're focused towards your goal, if your goal is down here. And like they're saying here, Dijkstra's can find all the paths to all locations, but A star only finds path to one location, or the closest of several. Because of that focus. Yeah, prioritizes paths that seem to be leading closer to a goal. And the heuristic can be simple or complicated. The heuristic could be just which direction it is, or it could be like something more complicated if you want. You read first search, but you think it's only taking forever because you're using Ruby? Maybe. Dijkstra's only improves it by prioritizing the shortest paths over the longer paths. Like they're showing, like what was the good example down here? I think it was this one, right? Dijkstra's versus greedy best first. We found our goal already, and breadth first takes a while longer to finally find it. I don't know why they say Dijkstra's algorithm. I guess it's because these are all even cost, and so it becomes breadth first. Dijkstra's is breadth first if the cost is uniform. That's like one of the rules, right? Like here's the comparison between breadth first and Dijkstra's, and you see how breadth first is going through that the green is supposed to cost more. Dijkstra's actually takes a little bit longer, but it finds a cheaper path around the expensive straight path. I don't think they have a good combination of those two to show it. Anyway, I'm gonna link this again because I really like it. That's what I used. In this case, Manhattan distance is a good heuristic. Yeah, that's what I usually use. It's just which way's closer. Manhattan distance-wise. Must be a lower bound of remaining cost. Yeah, it's like if the cost was 1 Manhattan distance, that's the shortest least. If the shortest path is the direct path, then it's Manhattan distance is the minimum cost, right? Okay. You know what I'm going to do? I'm going to measure the benchmark on this, then replace this huge vector and this ugly code with one that splits apart the path memory from the grid cost memory and see if it makes it better. If it's both better and looks cleaner, I'll go with that. If it makes it slower, I'll keep this and say that we're doing this as a performance optimization. So let's bench 15.2. Sounds like I'm gonna like put it in the gym to bench some weights when I say that. We're gonna bench 15.2. Warming up, and oh, it's actually pretty slow. 50 milliseconds. Out of curiosity, how fast is part 1? Oh, shoot, I can't do that. I need to remove the prints from part 1. Because that'll just kill the metric if it's just printing. So running the benchmark optimizes it, makes an optimized build, and then runs it many, many times and computes an average. Yeah, this is much faster, right? Part 1. Because it's a much smaller map. Yeah, 548 microseconds. So I'll just run that one more time to make sure I didn't change anything there. Hello, Dr. Padawan. How are you doing? You can use a non-optimistic heuristic, but then your solution will not necessarily be best path. It could overshoot by the degree the heuristic was too high. Right, it might not find the shortest path, right? I forget how that works. But we're not even using A-star, we're just using Dijkstra's. We're just expanding out with taking the cost into consideration until we hit the target. And using our priority queue guarantees we found the shortest path. Yes, I don't trust that regression. If I run, I think this is kind of noisy because their sample count is low. But it's on the order of 50 milliseconds, right? So let me clean up the code and use a hash map for the memory. So we'll call this one risk grid. And really all we're capturing is the risk. So that means I don't want to sell, I just want this number. All right? So vectors of U8s. And then I'm doing it again. I'm modifying part 1 where part 1 was good, we don't want to touch that. It's part 2 I want to modify. Risk grid. So removing the cell and just getting the risk out of it. Oh, Windows wants to update. I hope it doesn't update now. Can I pick a time that's not now? Let's pick a time that's not now. Pending restart. Let's schedule the restart to be like... Pick a time. Wait, can I pick tomorrow? I don't understand this dialogue. What does this mean? Schedule a restart. Schedule a time. We'll finish installing the updates when it's convenient. Off. What does off mean? Does that mean it's not going to do it? I'm just going to not touch it. Hopefully the stream doesn't end with Windows rebooting. F. No, we haven't. Yeah. That's almost a meme, right? Of just things being destroyed because all of a sudden Windows decides to update. Okay, so then I'm not going to do any of this resize junk. So it's just trim that map to characters and we're done. Collect. Okay, and then
The hole is done.
that means that I can get these two values right away. This is risk grid length as eye size. And this is risk grid 0 length. Okay, and then this is 0 to xwrap times super dimension. Probably a bad choice of word, but that's okay. Okay, and then we're just going to make, we're not going to do this resize junk.
How'd you get up?
This is the first time we need it, so let's make it here. Let mutable path grid equal hash map new, and then we do a path grid insert 0, 0 with what do I need from? I do need the whole step, so it's start. So now it should figure out, if I import this, that's a hash map from coordinates to steps. Thank you for the follow. So pop something out. So the cost so far, this is the risk grid. No, not the risk grid. It's the path grid. And I don't do it this way. I do a get with XY. So it looks a bit cleaner here. Oh, I needed to unwrap. Get XY and then unwrap to get the cost, right?
He has issues.
Borrow. We do a borrow and we do a get. Okay, and then this one is the risk grid. And we don't need to do a dot risk because it's there directly. Okay, then the next cell is I think we're just gonna do a entry or insert, right? So this is a I shouldn't even be calling it a grid. Let's call it path. Paths. Okay, so then this is paths entry x2 y2. So we get an entry, right? And so this changes a bit. You know what I can do is I can, if it's not in there, no, this is what I was trying to avoid before. I was going to say I could, if there is no entry, I can insert a default with a very high cost so that this greater than is always true, but I'm not going to do it that way. I really should turn these around, right? And then do a a match on this? Yeah, let's do a match. Match.
There we go, right.
We'll let the autocomplete fill the match arms. So, and then I can abbreviate this quite a bit, right?
Well, this is
I can just import that directly. Use that. And then I can abbreviate this out. So either have an occupied entry or a vacant entry, right? Oops. If it's a vacant entry, we're inserting it directly. Yeah, this is going to be a bit redundant, right? Anyway, that's got to be done. Entry dot insert. The value is the step.
Yeah.
This one. And then if it's occupied, then it's conditional. It's if entry dot value get. I forget how you use an occupied entry. Is it get? Yeah. If get cost
You get bonus.
is greater than next cost. So basically, if we found a quicker way to get to this spot, then we update it, right? Then we say entry dot get mute dot
Okay. Yeah.
or can we? Is there a way to say like just insert? Oh, there we go. So then it's just this again. All right, and then oh, I also have to insert that into the frontier. Right. So that has to be done. Duh. And we have to do that. Same thing here. I hate that redundancy. What's this next step gonna be? It's steps. Oh. Is that right? So, yes, we're storing it in two places. Okay. Then I should have just copied this. Because that's inserting that and then also using that. Okay, then same thing here. There's got to be a way to collapse that the redundancy away, just similar to an if. I just can't think of it right now. Okay, then at the end is just the paths. Paths at the get the goal. Get the goal. Unwrap that. We should find the goal. And there's no step as ref unwrap, it's just cost. There we go. What's this? We need to mutate the entry if we find it. And right, the risk grid is constant now. Okay, let me make sure I didn't break it. Okay, so now we get to bench it and see if this sped it up. If it sped it up, I'll go with it. If it slowed it down, I might undo. Although I kind of prefer it this way. It's easier to read. I have a feeling it's going to slow it down because we're using a hash map now instead of a vector, but we'll see. Hey there, War Eagle. I think I slowed down my solution a little bit. What extension do you use that shows all the extra information like types? That's Rest Analyzer. Highly recommended for VS Code. And I think there's also Rust Analyzer for Vim as well. Rust Analyzer is not only doing those inlay hints, the extra type information, but it also adds like this button to run the tests, and it highlights syntax errors with the squiggly lines. It does a lot of stuff for me. Highly recommended when you use Rust. Yeah, it regressed. It's twice as slow. Don't know why you weren't following before. You would argue, but he wasn't.
Try sounds.
Well, that's happened to other people before, where the follow goes away, and no problem. I don't mind. What else did I miss? That's for a daily maintenance schedule. What were we talking about? No reboot now. Right when my Windows wants to reboot. So okay, it's slower probably because we're using a map. You know, if we ditched the map and did our own thing with just a vector, then it would clean this up a bit, right? So then really we're just changing this, we've split away the risk grid from the paths. So now we just need to make the paths more efficient again. I think what I'm going to do is, now that we know the these values, or basically the range values, we'll just make one big vector. So let me do that. In fact, I could do that for the risk grid too, I guess. I could flatten that. Nah, that's okay. Paths is a... what's the best way to do this? Vector of options, right? Nones. Y range n times x range n as u size. So it doesn't know what a vector of yet, but that's because we haven't pushed anything into it. So instead of doing insert again, I gotta do 0, 0 equals sum start. Now it should get the hint about what the type is. No, why not? Oh, because it's a one-dimensional, so it's just 0. There we go. Now it knows it's an option, a vector of options of steps, optional steps. So, right, we don't do get anymore with unwrap. No, I still do the unwrap, but this part is different. It's paths y times x range and plus x. Ugh. One disadvantage of the inlay hints is while you're editing it can get really ugly looking. Okay, yeah, and again, when we index into a vector, it always wants the type to be unsigned size. Okay, and then what else? Okay, here, right, we can start just getting a mutable reference to it. Let next step equal mutable reference to paths, the same kind of thing that we did before. There. Where was I? Right there. Only we want y2 and x2. And then we'll say if next step is none, or next step... How did I do this in part 1? I can just copy what I did in part 1, really. As ref unwrap. Yeah, why don't I just copy this? Why don't I just copy the whole thing? Copy, 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 copy. There we go. Oh, I called it cell? Right, but that's because it had things other than steps. So we collapse this to just say next step instead of next cell step. And why can't I do that? Expected a step found. Okay, why? Oh, I have a collision here. What if I call this next path? I don't like it.
I have 15 gold.
I need to dereference. There we go. Okay, and then I can get rid of this stuff. All right, and then at the very end, it's just goal. What was this before? I can just copy from part 1. Yeah, this one, and copy the whole thing. Back to part 1 solution.
Let's go.
And this is paths, right? Oh,
What are you trying to
I combined the dimensions together, right? So it's goal
need to pick it.
1 is the y coordinates. That's correct. X range dot end plus goal 0 as u size. And there's no step anymore.
Plus 15.
All right. Make sure I didn't break it by running the unit test. Didn't break it. Good.
You're doing it
Run the benchmark. Hopefully I'm back to like 50 milliseconds or better. It should be about 50 milliseconds. And this is sort of a compromise between speed and readability. Basically split the cost array out from the path memory. And the path memory is a sparse vector, really. Oh, it's even better than 50 milliseconds. That's good. 31 milliseconds. I like that. I like that a lot. Now, I could combine parts 1 and 2 by making the super dim a argument, right? What if I do that? Gotta go fast. I don't feel like making it any faster than that. I mean, if Sarian was here, he'd probably say that he did it under a millisecond, and I'd say, good, congratulations, Sarian, but I can't. I don't have it in me today. It's past midnight, Hash map. Where do we? Yeah, we didn't use hash. Hash map is expensive. It turns out that's what I'm learning this year. Hash map is performance expensive. Vector is better,
the Hermes boot.
but you're at the cost of more memory potentially, right? I do feel like taking part 1. No, making part 2 the actual solution and parameterizing the super dim thing. Let me try that. So let's
That's easy. I could have
let's call this solve instead. Let's make that a function up here. Solve input and
I'm playing
like super dim as eye size string. Put the solution in there. Take capital super dim and replace it with lowercase super dim. That was the only place it was used? Oh, I guess so. Okay. So then part 2 inner is just solve input super dim. Part 1 inner should just be solve input 1. I think. Let's see if I got that right. One cool thing that I like about Rust is once you have some working code, it's relatively easy to refactor. Like you saw me just move all that code around really fast, and I didn't break the unit tests. It probably isn't any faster. I just refactoring or reorganizing the code is pretty quick. Also changing types. If you use a lot of type inference and your types are only in a few places, then it's really easy to change your mind about your types, because there are fewer places to edit. The only places that'll really break would be if you accidentally repeated yourself about the type, or if the change in type changed the API that of the type. Like you needed to change to a different API. Like going from vector to binary heap, I had to go from what was it? Push to it was. I had insert originally, and I had to go to push for a binary heap. I think it was a set. I went from set to binary heap, so I went from insert to push. Something like that. That's usually as bad as it gets. So I didn't change the performance. Hopefully I didn't hurt the performance of part 1 too much. It's going to do an extra memory allocation, so it might be slower. It's still 100,000 iterations in the sample, though. Or 10,000. It regressed a little bit. It's still sub-millisecond, though. You're right, Python, so your interpreter startup times are like the same as my runtime. That makes sense. And good night, Epsilon 1. Python has pros and cons, right? It's a dynamic language, so you can do a lot more flexible styles of coding. but it's going to be slower. Rust is faster, but it has these very tight constraints on types. They have to be known at compile time. There are some exceptions to that revolve around things like box, where you can erase types, but then you start killing your performance, right? Or does it? I forget. It makes things tougher.
It's a star for me.
I see it as a bunch of trade-offs. Pick the language that works best for you, right? I like having my constants up there. I don't like the name that I picked for that, though. Also, this is assuming it's a square. Maybe I want to have, like... How about if we call this, like, repeat? And then I add a repeat y here. And then I use repeat y for that. And then this is 1 and 1, and this is... And then make it, I guess maybe just say part 2 repeat x and y. And then make this second one a y. I like that better.
Man,
Best language is the one you can write well enough that the algorithm is the hard part, not the code itself. Yeah, and I also would add to that, what's really important is to pick the language that allows you to write it in such a way that when you come back to your code a year from now, you can still understand it, and anyone else that looks at your code can read it and figure it out, so that bugs don't have as many places to hide. Bugs love to hide in the parts of the code people can't read. I know this from a lot of experience. When I write code badly, I can really tell, looking at it just days past, not even weeks, but just I'll look back at it a few days later. I'm like, man, this code is really bad. I don't even know what I wrote. And if I wrote a bug in there, I'm not going to see it. But if I know when I write code well, when I can look back at it a couple weeks later and say, oh yeah, I can read this. And if I can read it, I'm more likely to see a mistake and catch the bug. Those are really important, because we spend a lot of our times taking bugs out. So if we write things in a way that it's difficult to put bugs in, that saves so much time, right? Even if maybe the runtime is not as good. How fast does it really need to be? For Avena code, as long as it takes under a minute to get the answer, then it's fast enough, right? We do a little bit of code golf when we try to make it faster and smaller, but it's really not as important as just having fun and learning something. So I want to improve that. This stuff, this kernel, you can call it. I could do this with a function.
my side? I'm on the right side.
Now that we know the repeat x, I don't need to do this division, do I?
Get the ugly.
Hold on. Oh no, I still need that. That's the fundamental size of the grid. We don't know until we've parsed the input. That's not the best name then, right? That should be like original width, XY or width or something. That's why you hate modern coding tendencies like YAML. They're optimized for typing, but really most of the time it's reading and analyzing. That's where the typeless approach, especially when writing is optimized by auto-completion and just typing fast. Why optimize for writing when you have those other things to speed up the writing already? Optimize for understandability in reading, especially if you work with other people. And if something really needs to run fast, well, number one, make sure that it really does need to run fast. And if it does, then I would still keep the original slow code as a reference, along with the unit tests, and have both the original readable code and the optimized code. Make sure they both pass the tests. And if you have to change the code, change both. That's probably the rules I would set if I was in charge. Am I doing too much indenting down here? let's see. Fundamentally, we have repetition with that while. And then the second level loop is for the neighbors. This one, I could invert this by having invert that and doing a continue. Maybe that would be better. If not contains or not, whoops, or not contains, then continue, whoop, and then outdent this. It's always nice when you can outdent something. Ah, so much better. It's like a relief of pressure. Every refactoring step, we follow the rules by running our tests again. Make sure they pass. I didn't do this before, maybe I should do it now. If in Rust, if you do a config test and then you make a mod tests and then you use super everything and then you close that off with an extra brace, then Rust Analyzer gives you this extra button here. I can run both tests at once, which is kind of nice. I should have done that from day one. I could turn this around. Ooh, I know how to write this better. Because the inverse of this is if let some. Yeah, I'm going to do it this way. If let some next path. Oh, no, I can't do it this way. Oh, no, I can. If let some path equals next path. And then inside here, we put this there. If it's less than or equal to, and then I can remove this as, ooh, that's nice. When I can remove that, it's really good. Then this becomes a continue, right? Then we don't need this at all in this outdents. One step of improvement, right? We could even comment this saying, stop if we've already been there and we at a lower cost, right? Stop if we've already been to this next step through a cheaper path. Which, when I see a comment like that for a block, it begs turning this into a function. But I'll think about that later. Yeah, I still have this habit of writing functions that are too big. I kind of want to reach, my goal is to make it so that functions fit on one page. So stuff like this should be a function called parse grid, parse risk grid. This should be something like compute sizes or something, and then this inner one for the neighbors should be like try path neighbor, try next step. And then I could, if I did all that refactoring step, then this outer function solve could be one page. But just a little bit here and there. Maybe just annotate with comments for now. Right, so find neighbor, skip if outside the grid. This is find the cost of visiting that neighbor. Stop if we've already been to that step. And this one is advance the path to the next step. There we go. So really we're doing 4 things in this inner loop. They could be 4 functions. This deserves a comment. Stop immediately if we've found the goal. And then this becomes try visiting all the neighbors from this point on the frontier. There we go. I don't know how to say your name, but hello. Is it Malarkey?
If you don't mind, I named
Interesting name. You prefer comments there, or else you need to keep jumping around really. There's a pro and con about comments in code, right? The pro is that it makes it easier to read code that's longer. The con is that it pushes back on the programmer to stop. It pushes back on the well, how do you say it? Let me try again. The con of this is that it disincentivizes you to further refactoring because you figure, oh, the comments make it readable enough. I don't have to make this function any smaller, right? Just read the comments. The second con is that if you change the code, it's like, especially if someone, if there's a lot of comments and the person changing the code doesn't understand all the comments, you could change the code and not change the comment, and you can have where the comment doesn't match the code anymore, right? Like if I decided to move this there, right? Now this comment doesn't match this code anymore because we're not just stopping, we're also computing the coordinates for some reason there, right? So there's two cons and one pro. So it's a little bit like, I'm a little bit hesitant to just leave it at comments. Some people say don't put any comments at all because you should just refactor until the functions are small enough where the code explains itself through the names of the functions mostly. And other people, the other side of there's another camp that says you don't need to refactor at all, just comment everything. There are pros and cons to both approaches. I kind of think that I'm more on the side of making the function smaller, but I find it difficult. I find it when I write code the first time, my functions are really long, and then to break it down, sometimes I'll comment it, and then the comments sort of are a reminder that, hey, I should probably think about, like, everything that I naturally made into a group like this. That's one group. That's another group. Those should probably be separate functions somehow, right?
Come back. Well, what's this?
And then if I were to make this a separate function, I would make the name of the function imply this comment, and then I could drop the comment. You need to comment to say why this function is like that sometimes. So you can make the comment of the block of code be the comment of the function that this code gets refactored into. Then the comment matching the name of the function, and that you can read that and they make sense put together, helps make the comment live longer, right? If you change the name of the function through refactoring and it no longer makes sense with the comment, then you'd be like, this comment is wrong. Functions have precise names, you don't need to jump around. True. Like if if the function is well named, you don't need to look at the internals. You can just trust that it performs what it says in its name correctly. Like this should be a function too, probably. This is like extract the cost to get to this point and as a string. You could probably leave this out of it. You could just have a function get cost at some coordinates, and it would do this multiplication for me. Probably the way I do this is, right now this is a vector. I would probably wrap it into a new type that did this calculation of y times x range n plus x for me everywhere. That's actually a point of fragility here. The fact that it's a one-dimensional array and it's sort of baked in there that to go from xy to the single dimension, you fold them that way. And if I put that into a type and formalized it would be better. But I'm tired and I don't think I want to do that right now. Oh, what happened here? This all got like mashed. I don't know. Oh, because I moved it into the test submodule, right? Yeah, I gotta line it back up. I'm just gonna make sure I didn't break anything, and I call it a day. All right. 2 days ago, how did you test part 2 where you had to see the character? Oh, I didn't. I cheated on that one because there was no unit test you could make because they said, as a human, look at the characters and what do you see? I just ran it, so I would just run 13.2, right? So, and I'm like, oh, that's UCLZRAZU, right? And then I improved it a little bit by getting rid of the dots and making the spaces. Instead of hashtags, I use solid blocks, and it's easier to read. But yeah, that one, you couldn't make a unit test because you didn't know what it would look like until you ran it. All right.
It was.
Unless there's any more questions, I think I'll call it, and I'll be back tomorrow a little bit late, I think. Maybe half an hour late. 'Cause tomorrow's Wednesday?
Good idea.
But in the meantime, let's go find somebody else to watch. Yeah, no problem. Probably no one else is doing Evan a Code. Sort of
Wait, aren't you full
getting
health?
late.
Skullface.
All my favorite streamers who do programming like Evan a Code are not streaming right now. That always sucks. You're welcome. I'm glad to do these streams. It's my way of
Skullface.
exercising my Rust coding. I don't get to do it enough in my job, so and I kind of like answering questions and stuff. I'm just gonna end the stream. I will see you guys next time. Okay, take it easy. Bye.